Alrighty guys, so here's my DRZ400 SM, and I've decided to do a couple little mods to it. So I've done a couple already, and yeah, some of the basic stuff I chucked on exhaust straight through FMF. So it's got the power bomb header and then just the slip on at the back. I've also chucked on up in here, if you can see, I'm not sure if you can see in there, but there's two switches. The first one is just a low beam switch, so just when the ignition gets turned on, the low beam doesn't come on straight away, so it saves the battery a little bit. And then the second switch is the fan, so I can turn on the radiator fan. You know, if I'm coming up to a set of lights that are notorious for being long reds, you know, I can just whack it on so the bike doesn't get too hot. Then here I've got some just some trail tech meters. So this one is just coolant temp, which just goes down to the radiator bolt just there. So it's, you know, not a perfect read of, you know, oil temp or engine temp, but it just gives a read of coolant temp. Then here is just your RPM/hour meter, so hour meter when it bike's off, and then RPM when engine's running. That just wraps around your spark plug just a few times, and just, you know, zip tie it off and make it nice and neat. And then, so today though, what I'm looking at doing is looking to make this a, you know, bit of a cross bike, so, you know, adventure bike or super motard. So I've got some second-hand wheels here, which this one here I've sort of started cleaning it up, so I think the rims come up, you know, really well. The hub's still, I'm still working on it, but it's come up a lot better than I thought. That's what it sort of was like when I got it. So this is the rear one I haven't done anything with yet. So, you know, there's the rim. You know, it's not too bad, but it'll all clean up. It's just surface rust. I'll put new bearings and everything in it as well, and I'll check all the you know, the spokes. But this one is cleaned up a little bit more to go. So they're the dirt wheels that'll go on it eventually. And today though, what we're looking at is running a new circuit from our battery. Running a new cable up 25mm fuse, so that's down here. So we're just going to have a connector straight here into our 25 amp. It's a miniature fuse, so that light there will go on when the fuse blows. And then obviously when it's connected to power. And then we'll run our cable up that can handle 25 amps. We'll run it up to our new cockpit. I'm going to do a new little cockpit here with a steel plate. So I've just bought some alley 2.5mm thick, and I'm going to make a bit of an L shape, you know, panel to go here and up here, and that'll hold some switches. That'll hold the ignition. It'll hold heater grips. I'm going to put some heater grips on. And so there'll be heater grip switch, ignition switch, then there'll be the low beam switch I'm going to relocate here. Then I'll do some auxiliary lights, so I'll put some lights on the side here, and then there'll also be a fan switch, which I've already got there, just relocating over to here. Then I've also got obviously these meters. I'll keep them roughly where they are, and I'm going to put a voltmeter in as well. So here's the gear that I've purchased already. So these are the switches that I'll be using for the low beam, the auxiliary lights, and the fan. So these can handle, you know, they're really rated for AC, but 15 amps at 125 volt AC. So you know, I've played around with some numbers, and, you know, they can carry 1 or 2 amps DC easily, so that'll be fine. So I'm using 12 volt DC. So a lot of you may already know this, but just for those who don't, so there's a few differences obviously between AC and DC, and when you're talking about switches. So first of all, it's AC is alternating current, so it goes between positive and negative. You know, multiple times a second. So for 50 Hertz it's 50 times a second, and that changes with the frequency obviously. But also DC is obviously direct current, so that means that it doesn't go from positive to negative multiple times a second. It just stays at a positive pressure of voltage. Therefore the switches actually take more load. There is no break, as in every cycle the switch gets a break in AC because it's going positive to negative, positive to negative. DC, it's just under direct load the whole time. Also, that means there's also a switching element. So when you turn a switch off, you're breaking the circuit, aren't you? You're opening the circuit. So that means that arcing between the contacts is different. So AC, it's easier to switch AC because it goes from positive to negative. So an arc theoretically should break on the negative cycle when you're switching. So that should break as the alternating current varies between positive and negative. But DC, it's on a direct current. It just flows consistently at the same pressure. Therefore, you need to have a better braking switch, so to break any arcing. So basically, you can get pitting on the contacts. So that's where sort of arcing between the contacts creates a little bit of pitting, and therefore you can get a less effective contact when you make the switch. But I just thought I wanted to explain that a little bit. So to summarize, this switch should be good still for very low amp DC, and it's low voltage DC, so there's not much pressure, so there shouldn't be much arcing at all. So that should break fairly cleanly at 12 volts DC. If it was a higher DC voltage, you would definitely not use this switch, as it's really rated for AC. So DC takes a little bit more, and you need to have a bit more heavy duty, but this will be fine for 1 or 2 amps, DC 12 volt. Here's the little voltage meter, so that'll just give me a direct read of the battery. That's it there, just 2 connectors. I'm going to wire these to some relays because I don't want any of this working when the ignition isn't on. So one relay is for the auxiliary lights, because basically I'll power the coil of the relay via the high beam. So basically my high beam switch and also the auxiliary light switch that I'm going to put in will operate the auxiliary lights. So basically if the auxiliary light switch is on, it won't run directly off the battery. It'll need to be powered from the coil of the high beam. So only when the high beam switch, which is up here, only when that is in the on position, so once it has power going through it, so which is controlled by the ignition, once it has power through it and this auxiliary light switch is on that I'm going to install, then the auxiliary lights will work. So if the ignition's off, and even if that's on and that's on, it still won't work because there's no power going through the high beam. But basically I want to still be able to use high beam without the auxiliary lights, hence why there's a separate auxiliary light switch going in. So I'll be able to use low beam on its own, high beam on its own, and then high beam and auxiliary lights as well. So that's one of the relays. So this is just a 4-pin from J-Car. So you can see there terminal 85 and 86, that's the coil. So you power that off whatever circuit you want it switching with, which will be the high beams. And then I'll run my actual power circuit for the auxiliary lights through terminal 30 and 87. So basically a relay allows you to control a circuit, control a higher amp circuit off of a lower amperage circuit, really. So because I don't want to run all my lights through this switch here, which isn't rated for, to high beam and these extra auxiliaries. I just want to run a separate circuit to power it. Secondly, the other relay is for just off the ignition. So I've got a USB outlet which will go onto the handlebars, and also I've got a merit switch as well. So that merit switch will go onto the handlebars as well. Not sure how I'll mount that yet, but the point is, this relay, I don't want, because I'm running a direct feed from the battery, I don't want these having power all the time. So if I'm charging stuff, I don't want it to drain the battery when the bike's off, so I'll wire this coil off of the ignition. So only when the ignition's on will these have power. So the ignition will power 85 and 86 terminal on the back here, and that'll bring the coil in when the ignition turns on, and then that'll close this circuit between 30 and 87, because it's a normally open, so that means in its de-energized state the switch is open. So when the bike is off and the ignition is off, there's no power on the coil, that switch is open. If it was normally closed, then there would be power from the battery to these when the ignition's off. That's what we don't want. So I've just got a 4-pin, not a 5-pin. The 5 pins have normally open and normally closed, but I don't need normally closed, so that's why I've gone with that. So yeah, like I said, it's a dual USB. One does 2.1 amps, one does 1 amp, I think. So 3.1 in total. And then just some connectors and stuff. Also, to make this plate fit, I need to get some. So I got this kit here. I'm not using it for its actual intentions. What I'm going to do is get rid of this plate here, this cross pattern, because that's where my switches need to go. I need room for all my switches, so I'm going to unbolt all of this, put these on, and then that will allow me to bolt my plate here without anything in this area. It's just 2 clamps going over the bars, which will give me room to run my switches and put gauges and yeah, all my running gear. So that's really what that's for. So this kit for the handlebar, to get rid of that X bracket that was here to hold the handlebars down, I'm doing this just to rise it up to give myself some room for the switches that are going to go in this area. One thing to note is it comes with all different bolt sizes, so there's 3 different sizes. So 1, 2, 3 there. Basically you want to use the one that maximizes the thread, so these 2 are really the options for me. So as you can see here, if I put it there, it really goes to the base, but it's actually a little bit too long, hits the bottom of that thread. So I'll probably end up using these here, because these are a little bit shorter. Still uses a lot of thread, but I like to maximize it if I can. So I'll probably just use this larger one, but just take 5mm off of it. I think I'll just cut the bolt down for 5mm. So yeah, just thought I'd show you that. The heated grips is interesting. So these go under your grips. The wiring diagrams aren't too bad that come with it, but the trick, one little trick is that can confuse people. So this is the little wiring harness here. Sorry about the camera work. This is the little wiring harness here that comes directly from your power. So for me, I'm going to run it off the ignition relay, because I don't want these having power straight from the battery. I want it running off my ignition, so when my key's off, these will not run at all. So power comes into this cable, and then goes out. So power comes into this cable and runs through to these 2. Now one's just a direct, goes to the terminal on the heated grip switch. Okay, so there's 3 pins there, and the other one has a resistor in it, but the instructions say go to put the resistor on the high terminal. But the reason why that is this is a mechanical switch, so when I flick this down to low, if you actually bell out, if you get a multimeter and bell out this switch, this mechanical arm here actually goes like that down to the low, hence why you put the resistor to this terminal, because it's actually between the common and this terminal. So this terminal is up, although it's the high indicator, it's actually the low terminal, so the resistor reduces current flow in the circuit, hence reduces the heat that the elements will produce. So that's actually the low setting. So that's a trap for young players there. So basically the instructions will tell you to connect the resistor to the high terminal, but they're talking about the labeling, so the one behind the high, but that's actually the low terminal, because the resistor reduces current flow to the low circuit to give you less heat, and the direct power obviously is just the high because it's direct full current, no resistor to reduce it. Okay, so that's basically my plan here, yeah, I might do a bit of another video, but that's just a quick rundown of what I'm going to do. So now I will draw up my plate, cut it out, and yeah, this was just $3, this plate, from just an offcut down from aluminium store, so it's pretty cheap. Most of this gear you can get fairly cheap. I think this was $6 at JCar, you know, $4, $2-3 for a bit of cable. The heater grips were $50 for the kit, because you're not getting any, you know, electronic control or anything. It's just a high-low switch, so it's a high-low-off switch. This was like $35 just from my local bike shop, just to remove that X plate I have up here. So that's just to remove that X pattern handlebar clamp. This Merit switch is just, I think they're better than a 12 volt car cigarette switch connector, I mean, so that's why I'm going with that. It's just a bit sturdier. And then the USB, this was about $30 because it comes with a handlebar clamp and like a fuse and yeah, full wiring kit, and then just some connectors in there. So I think all of this really only set me back about, I don't know, probably $150, including the $50 for the heated grips, and then the rest was about, you know, $90 worth of just switches and bits and bobs. And then obviously the lights, I'm going to mount the lights in here, I think. Don't have them yet, they're on their way. I've bought them, super bright lights, I got them, but yeah, from the States, so they'll take a little while to get here. But yeah, that's basically it. I think this is a 30mm hole, and it's just a pop, and then you gotta have a little notch so it doesn't turn. Obviously when you turn the key, there's a little notch you cut out. But yeah, I think that's pretty much a bit of a rundown on what I'm doing, but yeah, hope it helps some of you guys out there if you ever do anything like this. So yeah, enjoy. See you later.